Alrighty, CNT120, we're in the last section of Chapter 5 on some troubleshooting tools. So they have a bunch listed here for us, and we'll work our way down through. Or they should have a bunch in here, and we'll work our way down through. The first one they mention is the tone generator, tone locator, or toner and probe. This is handy for copper cabling. Its roots were really in phone cabling. That's kind of where it got started, but it has been adapted to data cabling. And this is really handy to be able to locate a wire in a location. So if I'm trying to locate where this cable, this termination here is, where it is in my closet, because maybe the label fell off, maybe it was labeled wrong, maybe things got terminated hurry and something's flipped around and you're trying to find where this data jack goes. Well, the toner probe comes in two pieces. This piece here is the toner. This is actually going to emit an electrical signal across the wire, across the cable. You'll see there's clip leads here for old phone cabling. There's even an RJ11 for old phone cable, and there's an RJ45 for plugging into a data outlet. Well, I turn this on, there's a battery in there, and it sends an electrical signal across the wire. Well, whenever an electrical signal goes across a wire, it produces a magnetic field. So this guy here, the probe, is now able to pick up that magnetic field. This little end out here kind of reminds you of like a little duckbill. This has in a sensor and a speaker, and I hold the button down, and it's trying to find those magnetic fields emanating. So I could then, I plug the toner in this end and it sends a signal across the wire. When I get to the closet, I get the probe out and I start working my way down the cables on the patch panel, if you will. And when I get to the one that has this on, you'll literally hear that signal. It's usually like a blue or a beep, 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 that kind of thing. You'll actually pick that up and you'll hear, in this case, the speaker's on the back. You'll hear that signal and that'll let you know that is the cable. And again, I might now notice it's labeled wrong, or now I know where it is, that sort of thing. Super handy troubleshooting tool to find a cable or cable run. It's one of those tools that when you need it, and you might only need it for a few minutes, but it's priceless because it helps you try to find that cable very quickly. And there's variations of this as well. There's variations of this toner and probe as well. Oh, let me back up here real quick. Once in a while in our cabling class, we'll get terminating, and students will accidentally flip two cables on the patch panel when they terminate. So when they go to test it later, it doesn't test out. I'm like, okay, let's get the toner and probe out, and we'll find that, oh, the cables got accidentally punched into the wrong spot, or we're not labeled right or something. So we find it, and we quickly relabel it. Problem solved. This allows you to find that pretty easily. There's such a thing as a multimeter, like this guy right here. This is able to test voltage, current, and resistance levels. This is handy for testing anything like power related, if you will. Maybe I'm trying to find out if an outlet is actually producing power. This would allow me to do that. And I can also test wire runs for resistance. If I have zero resistance across that cable, make sure it's not powered on. Make sure that cable's not powered on. But if I'm testing a data cable and I don't have any resistance across, then I know there's a connection. But if I get resistance, then I know there's a connection issue or there is no connection, one of the two. So this is able to do a lot of basic electrical tests. But you got to make sure things are not powered before you start plugging this into things. If I'm testing for voltage and outlet, that's okay. But if I'm going across the data line, I need to make sure there's no power across there, if you will. There are continuity testers. Yes, these are the typical tester that's in our toolkit. Looks something like so, something like this. This allows me to test my data cable for, is there a complete path? This works. This end here has a battery in, and it literally will send a small electrical signal down the 1-2 wire pair. This goes on the other end of the cable, or end of the cable run. It'll loop the signal back to here to the source. And if you get a complete path the whole way through, that little light will light up and let you know, yep, you have a complete circuit on, wire pair 1-2. And then 3, 6, and 4, 5, and 7, 8, each of the wire pairs. So ideally, when I test it, I see all 4 wire pairs are connected and it'll show up that it's passed. And the other end shows up the same thing. That's what I would see on this end over here. If I have problems, though, and this one actually has a fault check button, I can go through and start checking each wire pair to let me know if there's an issue. Well, if there's an issue, It says there's a fail. As I go through the fault check, it'll let me know this particular wire pair is open. That's what I'm seeing there. That would let me know that wire pair is cut or not terminated or something. There's a break in the wire. If there's a short, two wires touching that shouldn't be, actually, let me back up here real quickly on the break. Wire break can happen. Maybe I just didn't terminate well at the patch panel. Maybe I didn't terminate well at the outlet jack that's in the office. So it would let me know what wire pair to be looking at to double check. So in this case, I would go to the patch panel and double check that, the 4 or 5 pair, the blue pair, if you will, and see, hey, is this terminated well? If it's not, I would re-terminate, test again. If that is not the issue, then I'd go check the outlet and check that. Maybe I take the outlet apart and re-terminate that and then test it again. A wire short, I now have 2 wires touching that shouldn't be. Again, the first check, it'll let me know it's failed. When I go through the fault check, it'll tell me which wire pair is shorting out. Well, this might happen when, and this has happened to me, when I'm terminating the outlet, I do the jacket stripper a little too many times, and it starts cutting through the little wires inside. Well, when I terminate those and start putting them in the outlet jack, sometimes the white orange and the orange wire, those 2 little nicks line up to each other and short out. And then I would know, okay, that is the wire pair I need to redo. Again, I would check the patch panel and then I'd check the outlet. In this case, it's probably going to be the outlet. I would carefully take it apart, cut that end off, re-terminate, and try to make sure I don't have those 2 wires shorting out. Reverse pair, if I get 2 wires in the wrong spot, I flip the white, brown, and brown around and they shouldn't be. When I do this, again, it'll show a fail. I go through the fault check. It'll let me know what wire pair is crossed or they're flipped over. This tends to happen when you do like patch cables. Slide those wires in the connector. They tend to flip-flop on you, and I get the brown, white, brown instead of the white, brown, brown. And it'll show me that wire pair is reversed, and I would need to re-terminate that end. I'd find the end that needs to be re-terminate at that end. There are some that are able to test a little bit more. This style here is actually able to test a little bit more, give me a little bit more input. This is your basic cable tester like we had before, but sometimes it gives you a little bit more information. And then there's some that's actually able to do a wire map for you, actually show you this kind of display to let you know what might be wrong with the cable. Here would be the correct pinout. Here would be a wire pair got flip-flopped. That would be a reverse pair. Here, 2 wire pairs got flip-flopped. That'd be a cross pair. And then if I have wires incorrectly wired, I might be splitting a wire pair apart. So on a meter, if I start looking at these, here's the correctly wired. I know it's a little blurry, but you can still see the wire map across there. It's actually showing a complete path there. If I have a wire break, a break that, a cable is not terminated as it should be, it'll literally show me the cable, the wire that is not fully connected. And that'd give me an idea where I need to start troubleshooting. If I have a wire short, this is just showing you these 2 wires are touching and they shouldn't be. And sometimes it'll even give you a distance and it'll let me know it's on this end or that end of the cable run, which is very handy. Here is a reverse pair where I have just 1 wire pair flip-flopped, and that lets me know the wire pair I need to check. So some of these are very handy to give you a printout, almost a printout or a map of my cable to let me know where I need to start troubleshooting. When I move over to fiber, fiber has some of its own tools because I can't use the copper ones. There is such a thing as called a visual fault locator. Think of this as a really strong laser light that I shine into a cable. And if I have a perfectly working cable, the light literally comes out the end. And again, don't look into that. Do not point that in your eyeball. It's a strong laser light, okay? But if I do have a break in the cable, it literally lights it up because it gets to that point and it starts flooding out almost like a broken, garden hose kind of thing. The water just starts, squirting out or whatever. In this case, the light just starts kind of seeping out and it'll let you know that's where the break is. And that's what they're even showing you here. They're showing you right there. It's lit up. That's where the break is. That is handy for dealing with fiber optic. And again, there are some other tools used for fiber optic as well, but that's kind of the common continuity one, if you will. There is such a thing as a cable performance tester. This is able to test all kinds of things with signal loss, crosstalk, etc. on my cable. And these can actually do distance measurements either for copper or fiber. That's what the OTDR or TDR is, time domain reflectometer. It basically sends a signal down the wire. It hits the other end, bounces, it comes back, and it times it. And from that, it lets you know, hey, this cable's about so long. And if I know the cable is supposed to be, 50 meters, but it shows up that it's 30, then I know there's an issue at about that distance away from me. To, again, let me know where I need to start troubleshooting. This would be a certification, copper certifying meter here. And this would be a fiber one here. And they actually do, both of these actually have two. I'm just showing you the meter end on this one. They do have a remote end on each one of those. Okay, just so you know. And here is another type of meter. I think it's almost a duplicate of this guy out here. Yeah, it is. And there is such a thing as an optical power meter as well for fiber optic. On a cable run, I would need to know the strength of the signal moving through. I think they call it the link loss in the book in there. I would need to know the signal, the expected loss across that fiber run, and I calculate that. And then when I actually terminate it, put the cable in place and terminate it, I measure that with a power meter like so. And as long as my loss is not greater than the calculated, then we should be good. We should be okay to use that cable run. If it's more than the calculated loss, then I might have some terminations that need to be redone, or there's something wrong with the cable. So the power meter lets me know the signal loss against my calculated expected loss. And as long as it's within parameters, we're okay. If not, I might have terminations I need to redo. And that's what the optical power meter is all about. We actually have one of those in the lab that we use, along with a visual fault locator that we use in our lab room with the cabling class. We also have wire mappers for the copper, and we also have copper certifiers as well that we use in the cabling class, CNT120. So there is Chapter 5.